Welcome back to Applied Mathematics. In this video, I want to go through a quick review of solving proportions. Let me get my head out of the way and we will dive right in. Remember that a proportion is any equation that can be written in the form A over B is equal to C over D. Right? A proportion is an equation that claims that two fractions are equal to each other. And in order to solve a proportion, you utilize what's called the cross product test. You test the product of the things that are diagonally across from each other on your equal sign. In this case, that is A times D, and that is B times C. If these things are equal, then the original proportion is equal. And if the original proportion is equal, then these things are equal. It gives us an equivalent equation that we can solve pretty readily. So let's just dive in with an example here. I've got some, well, kind of ugly decimal numbers. Let's assume that these are all approximate values. 4.7 over x is equal to 9.5 over 11.8. So following the cross product test, that means that it must also be true that 4.7 times 11.8 is equal to x times 9.5. My calculator tells me that 4.7 times 11.8 is 55.46, but since I really only have two significant digits, I'll round it and call it 55. Then I get x by itself by dividing both sides of the equation by 9.5, which my calculator tells me is about 5.8. As we talked about with solving equations, the fact that the x is on the right side of the equation really plays no part in this whatsoever. It is perfectly fine, and that is our solution. So the cross product test generally takes a proportion and turns it into a linear equation that we can solve using the tools of linear equations that we've talked about previously. And most proportions look very similar to this. The process of solving proportions usually doesn't get too complicated. One of the ways that it can get a little bit more complicated is if we don't have just x and we have something else. Another way it can get more complicated is if x appears in more than one place. So let's go to that example next, where we might have something like x minus 1 over x plus 1 is equal to 27.5 over 32.6. The process is the same, but you have to take a little bit more care because in this situation, it's a little bit easier to make an algebra mistake. So we have to make sure that when we multiply across, we get all of x minus 1 multiplied by 32.6, and all of x plus 1 multiplied by 27.5. Using the distributive property, that's 32.6 times x minus 32.6 is equal to 27.5 times x plus 27.5. We've got variables on both sides of the equation. So I'm going to get all of the variables to one side of the equation by subtracting 27.5x on both sides of the equation and combining some like terms. If my calculator can actually listen to buttons, it will tell me that I now have 5.1 times x minus 32.6 is equal to 27.5. add 32.6 to both sides of the equation, and I get that 5.1x is equal to 60.1. Divide by 5.1 to get x by itself. I get a really hideous number, 11.78, etc., etc. But 5.1x, I only have two significant digits there, so rounding to two significant digits, I get that x is 12. All right, that's the basic idea. Again, hopefully this is familiar to you. Hopefully this is the sort of thing you have seen in the past. In the coming weeks, we're going to build on this basic tool and use it as a way of solving several different kinds of problems. But for right now, I think that is enough for this lesson. Thank you as always for joining me. I'll see you next time.